So in this video, we are going to learn in detail about all the reactions. This is like a continuation video for the ferrocene. So in this case, first we will see Vilsmeir-Haack reaction. Okay, Vilsmeir-Haack reaction. Haack reaction. Okay, very important reaction. So what will be formed is ferrocene. Ferrocene is here, and then this ferrocene is converted into its aldehyde form. Okay, one CHO group is added here. How this is happening is in the presence of POCl3 and then formamide, dimethyl formamide. So what is dimethyl formamide? So nitrogen group is there, 2-methyl group is added, dimethyl formamide. So formaldehyde, formamide, what is the reaction? HCONH2. So this is called formamide. Okay. Instead of this hydrogen, 2CH3 is attached. Okay. So NCOH. So this is called formamide. So now we will discuss in detail about the mechanism. If you don't want to know about the mechanism, you can just skip it, but you have to memorize it. Okay. That's the only way if you don't want to learn the mechanism. Okay. So firstly, what will happen is we have our POCl3 here. So basically phosphorus can have 3 bonds, 5 bonds. So these are all the stable bonds for phosphorus. Okay. And then our formamide is here, CO, N, CH3, CH3. Instead of CH3, I'll add Me later on. Okay. So now what will be happening is first a lone pair is present in this nitrogen. That lone pair will go here, and the two bonds from here will go and attack our phosphorus. Okay. Now chlorine is a very good leaving group. Okay. Chlorine, iodine, these are all very good leaving groups. So what will happen? So H is here and then C is here. Now this oxygen is connected to our phosphorus, right? Oxygen is connected to our phosphorus, and this phosphorus now has only 2 chlorine. Okay. Now here a double bond will be there. Now this nitrogen is having 4 bonds. So that is not, it is basically having 1 extra bond. So it is having positive charge. Okay. So now the next step will be what? So now this particular carbon is more like prone to any nucleophilic attack. Okay, so our chlorine which left, already 1 chlorine left, right? That chlorine will go and attack this carbon, and this 2 electron will go back to nitrogen. Okay, so carbon, nitrogen got back its lone pair. Okay, and then hydrogen, now chlorine is attached. Okay. So now this POCl2 will be, PO2Cl2 will be released as a leaving group. See, this will go back here and this will go back here, and then they will act as a good leaving group. Okay, C double bond N. So now it will have a, like whenever it is having extra bond, it will have a positive charge, right? So now this is the new structure that is formed. Okay. So this is the electrophile. Okay, so this is the electrophile. Now electrophile is ready. So now our ferrocene, I'll just draw this like ferrocene. I'll just draw the half structure. So now this ferrocene will attack, always it will attack the carbon, and this nitrogen will get back its lone pair. So nitrogen got its lone pair, and then chlorine is there. Now this is bound to our ferrocene molecule. Okay. So now what will happen is this lone pair will go back and this chlorine will leave as a leaving group. Okay, another iminium ion. So this is like the iminium ion. So iminium ion is formed. Okay, iminium ion. So now here it is bound to our ferrocene group. Okay, so now what will happen is we will add water. Okay, water will go and again this is a nucleophile. So it will go and attack the electrophilic carbon. So this is the electrophilic like electron deficient carbon. Okay, so again this is going back here. So hydrogen C and then nitrogen OH and then our bond and then Fe. Okay, so here what is there? OH and then H, OH2. So now this oxygen will have a positive charge because oxygen has 3 bonds. Oxygen should have only how many bonds? 2 bonds, but in this case it has 3 bonds, so it is not very good. So it is leaving. Okay, here CH3, this nitrogen will have CH3. Okay, so now what will happen is this hydrogen will transfer here. So what will happen? Hydrogen C OH and then nitrogen H CH3 CH3, and then our group is here. Okay, So now this nitrogen will have positive charge. Why? Because it is having 4 bonds. Okay. So now what will happen is, so this electrons from here will come here, and now this group is like a very good leaving group because nitrogen will have 3 bonds and 1 lone pair. So it is a very good leaving group. So OH and then H and then our ferrocene group. And then here positive charge because oxygen is having 3 bonds. So the leaving group was like this. Nitrogen, Me. So whenever nitrogen is getting a positive charge, it will be a very good leaving group. Okay. If the nitrogen has 3 bonds and 1 lone pair, it is a very good leaving group. Now this H plus will be removed. Okay. Minus H plus. So COH and then our ferrocene group. I hope you understood this mechanism. Very easy mechanism if you understood the main concept. Okay. So next we will move on to the Mannich reaction. Mannich reaction. So Mannich reaction, what will happen is formaldehyde, they dimethyl formamide. Here formaldehyde, you have to use some trick to remember these initial reagents. Okay. And then dimethylamine. Similarly dimethylamine is the initial reagents. So what will happen is, initially this will form an electrophile. So how we can see, there also initially an electrophile is formed, and then that electrophile will attack, always electrophile is going to attack our particular ferrocene. Okay. So this lone pair will go and attack here, and this will come here. Okay. So C and then O minus and then H and then nitrogen CH3. C, instead of CH3 I am just adding C. Okay. So now this nitrogen is having positive charge. Okay, so this proton, this H plus will go and attack here, and this lone pair will go back to the nitrogen. Okay, C, OH and then H and then N, CH3 and then CH3. Okay, so now what will happen is H plus is added. Okay, acid will be present in this reaction, acid will be present. So that H plus will go and attack our OH. Okay, OH. OH2 will be formed. So this H plus is attacking OH, so OH2, so it will be a positive charge. Okay, and then nitrogen and then carbon. So now what will happen is this lone pair will go here, and this H2O is now a very good, H2O is a very good leaving group. Okay, so H, CH, double bond, N, CH3, this is a positive charge. Okay, so now this is the electrophilic group that is formed. Okay, now this is the electrophile. So now the our ferrocene molecule will be like this, and this ferrocene will attack this electrophilic carbon, and this will go back here. Okay, so what will happen, our ferrocene is here. I am just drawing it, not drawing it completely. Okay, ferrocene is here, it is attached to carbon, one hydrogen, another hydrogen, and another one nitrogen, and CH3 and then CH3. Okay, so this is the final reaction. Further from this particular reaction, consider it is reacting with MEI. What is the charge for this MEI? So always halides will have negative charge, so this will have positive charge. Okay, so now what will happen is the lone pair here. So these are further reactions. Okay, so the lone pair here will attack, of course, the positive charge. Okay, so now what is happening? The ferrocene is here, and then a CH2 and then N, CH3, CH3 and another one CH3, 3 times CH3. Okay, so now this will have a positive charge, right? So now whenever it is having a positive charge, it is going to be a very good leaving group. Okay, so there are many reaction possible here. We will see 3 reaction, NaOH with NaOH, and then sodium amalgam, this is a reducing agent, and then urotrophin. So you might have learned about urotrophin, very important reaction, CH2 6 and N4. This is the urotrophin structure, it will give aldehyde. Okay, so from this what will happen, you will get with urocene, you will get ferrocene aldehyde. You just have to remember this. Okay, urotropin will always give aldehyde. In the case of here, this OH minus will act as a base, and it will attack here, and this will be leaving group. Okay, so our ferrocene is here, and then OH is added. What is the leaving group? Nitrogen with 3 CH3 groups. So this is a very good leaving group. Okay, in the case of reduction, basically there is a gain of hydrogen, right? So what will happen is the CH2 is there, so in another one hydrogen will be added here, so CH3. So here another one hydrogen is added. Basically reduction is happening. Okay. Consider our ferrocene is here, and then this ferrocene is reacting with BbR3, and then CH2Cl2 is also present as a solvent. So what will happen? Our nucleophilic will go here, and then one bromine will be going as a leaving group. Boron will have 3 bonds. Okay, so 3 bromine was there. If in case our ferrocene is coming here, one has to leave, right? So one bromine will leave. So ferrocene is here, and then boron Br2. Okay, can you understand? Because one has left. Okay, now we are doing NaOH. Consider hydrolysis will happen, base hydrolysis will happen. So what will happen? This OH will go here, and this bromine will be leaving. Okay, so what will happen? One boron Br, and one is here. Another time if you add another OH minus, another one also will be leaving. Okay, so the final product after hydrolysis will be OH2. Okay, and this is the ferrocene structure, anti-ferrocene. Then if you see another reaction, consider ferrocene is here. So I'm giving so many reactions so that you are not confused with any reaction. Okay, ethyl, and then CO, CH2, COCl. Okay, and then AlCl3. So if you have watched my previous video, this is very easy for you. Always this AlCl3 will accept one chlorine acetylation reaction, chlorine minus. So what will be the final product? So an electrophile will be formed. Okay, so whenever Alc is present, Friedel-Crafts, it's like Friedel-Crafts. Okay, this will get a positive charge. Now this is the electrophile, so our nucleophile will go and attack here. Okay, so it will look like this. So our nucleophile is attacking this CO group, CH2 COOET. Okay, so now basically in this reaction we will try to bind these two cyclopentene group together. For that what they are doing, see, second one we are going to reduce, okay, reduce the CO to CH2. Okay, so our it is here, instead of this CO is reduced to CH2 with platinum. Okay, platinum is a very good reducing agent. Then what is happening is hydrolysis. So acid hydrolysis or base hydrolysis, any hydrolysis you can use. So whenever hydrolysis is happening, what will happen? H plus and OH minus will be added. So there is a mechanism for this. I hope you know that. So basically you can easily find oxygen is more electronegative, so it will so H plus and OH minus will be there, right? So oxygen is more electronegative, so it will gain what? Negative charge, and this will have a positive charge. So negative will attack positive. So and then ETOH will attack negative, right? So it will look like this: CH2, 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 CO, and then OH plus ETOH. So ETOH is the byproduct, like, okay. So now if you react it with PCl5, so this is a chlorinating agent. This one SOCl2, these are all converting alcohol to chlorine. Okay, so there is a mechanism for that also, but just remember these are very important: PCl5, SOCl2. So basically they will convert this OH to what? Chlorine. Okay, very easy mechanism only. If you want, you can check the mechanism also. Okay, and then again if you are reacting with another ACl3, what will happen? This chlorine will come in here, right here, and then now our ferrocene will have a positive charge, right? Our ferrocene will have a positive charge here. Okay, so what will happen in this step is, so this nucleophile, our second nucleophile, will go and attack here. So they are basically binding the two cyclopentadiene ring. Okay, so here this CO is going to attack here, CH2 and then CH2 and then CO. Okay, so now again we can reduce zinc amalgam. This is a very good reducing agent. So the CO is reduced to CH2, and then basically an alkyl group is binding the two cyclopentadiene ring in this particular reaction. Okay, So let's move on to the next reaction. This halogenation and nitration, very important. Halogenation and nitration, these the electrophile like this NO2, if you are adding NO2 plus and then this X plus, so these are very good oxidizing agents. So basically if you are adding in case NO2 plus to our ferrocene, what will happen is it will be converted from 2 plus to ferrocenium ion Fe3 plus, because these are also oxidizing agents. So they are not used directly. So this ferrocenium ion is formed. So once ferrocenium ion is formed, it will not undergo many reaction because it is only a 17 electron species. It is already electron deficient, so it cannot donate some electrons to someone else because it itself is electron deficient. But our ferrocene is electron rich. Okay, that's why electrophilic substitution reactions are happening. So how to undergo this nitrogen and nitration and halogenation means first we have to undergo metallation. So already in my previous video I have talked about how to do this metallation process. So consider if it is the ferrocene here and then if you are adding butyl lithium. So lithium plus and this is minus. Okay. So always nucleophile attack the electrophile. Electrophile here is lithium. So lithium like this we can do if in case the same butyl lithium is done with TMEDA. I have already told you this will cause what dilithiation. Okay, di substituted product. Okay, so 2 times lithiation. Similarly for mercury also I have talked about it. You can check my videos. Okay, now we will see the further reactions. So consider our lithium. So whenever only one lithium is substituted means only mono substituted further reactions will be happening. Okay. So there are so many reactions that we can see. NBS, so N-bromosuccinamide. So this will cause bromination. So ferrocene structure and writing it in short form. So bromine will be added. Okay. And then SiCl4. So what will happen is, so basically this one is plus and our entire compound will be in minus. So it will go and attack this Si and one chlorine will go as leaving group. So remaining what will be present? SiCl3 because one chlorine has left. Okay. Similarly, so everything the same procedure only. Um, consider Bu3 essential, which will be the leaving group. Of course, our chlorine is going to be the leaving group. So remaining what is present? This Sn and Bu3 will be present. Okay, ferrocene. And if you another reaction, if you see NH2 OMe. So in this case, either NH2 minus can be the leaving group or OMe minus can be the leaving group, which is good leaving group. So whenever it is a leaving group, it should be less basic. Okay, so less basic groups are good leaving group. So this is more basic. If you know the pK values, you will know this is more basic, this is less basic. So if you compare these two, which is a very good leaving group, OMe. Okay, so what will happen? Our ferrocene will be here. This OMe will be the leaving group. So NH2 minus NH2 will be attached to the ferrocene ring. Okay. So if you are reacting or the same thing, I am writing the reaction for this only. Okay. So if you are reacting with N2O4, so directly remember it will give NO2. NO2 will be the product. Okay. And then if you are reacting with consider CO2. CO2 already we know whenever there is a CO2 just add the COH. There is no doubt whenever there is a CO2 of course COH will be the product. Okay. And then consider it is reacting with CH2O and then H plus. The same everything I am talking about for this only I am writing the reaction. Okay. What is the CH2O? CH and then CO. So this is the group. Okay. So now what we have to do is, so consider this is our ferrocene. So this will go and attack here and this O will come as O minus. So what will be the product? or ferrocene is here, and then C is here, O minus, and then H and H. And then H plus is given, right? So that H plus, if we add, it will form what? CH2OH. CH2, this H will be attacked by this H plus CH2OH. Just know how everything is formed. So the same reaction, okay, basically I am talking about, for this only I am writing the reaction, don't forget that. So next reaction, if you see, if you're adding iodine, so how easily you can remember, iodine will be added, that's it, okay. Then S8, so whenever S8 is added, just the sulfur with the lithium. So the lithium is present here, right? So the sulfur and lithium will be there as it is, okay. And if there is S8 with H plus, what will happen is this H plus will go instead of lithium. So instead of this lithium, this H plus will be there, okay, because H plus is given, okay. Then BH2 and then chlorine. Now if you see, this will be the leaving group, so what will be the product? P, and then remaining PH2 is present, okay. Then another bore, BOBU, and 3 times. So which will be the 3 times is present? One of the OBU minus will be the leaving group, that's it. So just remember this, okay. OBU and then 2. So here further hydrolysis is possible. Further hydrolysis, if you did it, it will give what? So basically B and then OBU will be present like this. So here H plus, here OH minus will go. Okay, so BOH2 will be the final product if in case hydrolysis was also taking place, okay. So next, if you see, there are further reactions where consider there is a HgCl group and this is a ferrocene ring, and here I am adding butyl lithium. Just understand the charges here. This is positive charge, this is negative charge. This now what will happen is this butyl will attack here, okay, or Hg. So what will be the product? HgCl and butane. It will come out as a byproduct. So remaining what is there? This plus, and here it will be minus, right? So that will go on attack. So lithiation. So lithiation can also be done by this way, okay. Similarly, consider another reaction where initially our ferrocene with aldehyde is present. Just remember all these reactions, okay. Bu lithium, okay. So now what will happen? This is minus, this is plus. So here what will be there? This will be minus, this will be plus. So this Bu and Br will react, and then our compound will get the lithiation. So these are some of the ways to lithiate, okay. So another reaction, if we see, consider our HgCl is present with Fe. So I hope you know how to get this HgCl. So basically we will react it with HgOAc2 and lithium chloride KCl. You will, from ferrocene. You will get this. In previous video itself I have explained how this reaction is happening, okay. And then now we initially consider we are reacting it with another cyclopentadienyl group. So what will happen? This cyclopentadienyl group will go and attack here, and this chlorine will leave as the leaving group, okay. So what will happen? Hg will be present, and our 2 ferrocene ring is attached by a mercury group, okay. And then whenever a metal like EAG or COCl2, these are present, just remember the 2 ferrocene ring will be binding with each other. So whenever there is a metal like Ag or something, or COCl2 also, okay. Now we will see more about such type of reactions later on. Then whenever phosphorus is present, silicon is present, there is a case. Consider this is our lithium, and then ferrocene is present, lithiation. So pH FeCl2. Okay, so now 2 times it is lithiated. So 2 time lithiation, how we are adding a TMEDA, so 2 times lithiation is happening. Here also we are going to add TMDA. So what is happening is initially this will attack and one chlorine will be leaving. Okay, so pH, no, phosphorus, pH, and then Cl. One chlorine is left. Okay, so now another one metal with lithium is present. So the next one will attack here and another chlorine will be released. So whenever 2 times it is present, these phosphorus will basically bind the ring. So these phosphorus and silicon will basically bind the ring. Okay, so consider HgCl. So if you are adding HgCl here, it will not bind the ring. Instead, it will just add like HgCl, Fe, HgCl separately. HgCl will be added separate, HgCl2. Okay. So what will happen? Or this will go and react here. One chlorine will be leaving us. It is adding separately. It is not binding with each other, right? But whenever phosphorus is present, okay, remember phosphorus and silicon. So whenever phosphorus or silicon is present, basically they will cause binding. Okay. So another reaction, if you see, it is here, and then Fe, and then lithiation dye substituted product, and then consider it is reacting with Me2SiCl2. See, silicon is there, of course it is going to cause binding. Okay, one time it is attacking, so one chlorine is released. So one chlorine is released, so silicon, one chlorine, remaining Me will be present as it is. Okay, and then Fe and rest. Another time what will happen is another ring with lithium is present, right? So this will go and react here, and so there should be a leaving group, only then it is possible, of course. Okay, 2 chlorine is present, that's why this is possible itself. Okay, so Si and Me, and then Me. Okay, so another reaction with this same reaction, consider you are adding CO2. What will happen is both the lithiation will be converted into COH, because both are lithium, right? So both will be, if one lithium is present, one COH will be added. Okay, then moving on to another reaction, see, Bu3SnCl. So what will happen? This is Sn, initially SnBu3. Separately it will be added. This chlorine will be the leaving group. For both of them it will be happening, but they won't bind the two things. Only for silicon and phosphorus there will be binding of the two rings. Okay, and then for silicon SiCl4, guess the answer, it will be causing binding. Okay, so basically 4 chlorine is present. So what is happening is, so initially this is binding and then 2 chlorine will be left out. So this is reacting with another one ferrocene group, ferrocene with lithium group, and what will happen, this is binding, this will bind with this one. So since 4 chlorine is present, the product will look like this. Okay, it is basically like 4 bonds. 4 bonds are formed, like 2 ferrocene is literally connected in this case. Okay, so another reaction, if you want to see, consider our ferrocene is ferrocene with BOH2. I hope you know how this BOH2 is formed. It is reacting with AgO. Just remember, whenever there is a metal, what will happen? It will bind to ferrocene group. So whenever there is Ag or COCl2, I have already mentioned. Okay, consider it is reacting with CuBr2 or CuBr2 or CuCl2. What will happen is, so basically it will just brominate it, or what, chlorinate it. So the ferrocene, so from this will be converted into bromine or chlorine. Okay, so there is something called Hughes ammine. Okay, Hughes ammine, so very important. How to prepare Hughes ammine, they may ask you. Okay, So our ferrocene is initially present, and then CH3COCl and AlCl3. So this will basically acetylate, Friedel-Crafts acetylation, right? And then lithium CO, I'll write it like this. Lithium aluminum hydride will basically cause reduction. So what will happen is, how this will look: lithium H, H, H and H. Since lithium can have only 3 bonds, but it has 4 bonds, it is gaining electrons, so minus, and lithium will be in plus charge. So this hydrogen will go and attack here, and this will be coming here. Okay, so what will happen? CO minus, CH3. Okay, and then hydrogen has attacked from lithium, so this will be also reduced. Okay, so this is further reacting with acid. So what will happen is, this OH will gain another one hydrogen. So this will have a positive charge now, CH3 and CH3. Now this OH2 will be a very good leaving group, right? So what will happen? Or this is here CH3H. So this left along with the electron. So this is now having a positive charge. So now in this case, if you are adding or amine group, what will happen? This will go and react here, and so this product is called Ugi's amine. Okay, H and then Me2. Okay, so this hydrogen will be released. So this is called what? Ugi's amine. Okay, so very important reaction. And the reaction, if you see, ferrocene is there, lithium is there. It is reacting with acetone. Okay, acetone, how it will react? Basically, this is in plus charge, this is in minus charge. So minus will go and react here, and this will go upside. And then this will have a OH group. This will convert into OH group, remaining which will be acetate. Okay, so another reaction is, our consider aldehyde is present, CHO. So if in case you want to reduce this aldehyde into alcohol, CH2OH, or with ferrocene, you can add baker's yeast. Okay, baker's yeast, or we can also add horse liver alcohol. So these will cause reduction from CHO. Reduction will cause CH2OH. Okay. Another one important reaction, CO and then CH3 is here. Consider PPH3. This is like a wild, okay, yield if it is given. Okay. So this is having a negative charge, this will have a positive charge. So what will happen? This negative will go on attack here, and this will come here, right? So our ferrocene is here, CO minus, CH3, and then our CH2, and then PPH3. Okay, so this is having a positive charge. This negative charge and positive charge will react with themselves. So it will form something like this, oxygen and this positive charge. Positive charge is attached to PPH3, and then carbon is attached to CH3, and then CH2 is present. So this CH2, these are connected. Okay, these are connected with each other. Okay, can you understand this oxygen? This oxygen is reacting with this phosphorus. So oxygen I have written, then oxygen is connected to carbon, and this carbon is connected to CH2, and then this CH2 is connected to phosphorus. It is forming like a ring. So in this ring, what will be happening is, so this will go here and this will come here. Basically alkene is formed. Very important reaction, alkene. C double bond CH2 and then CH3. So remain byproduct will be POPBH3. Okay, so this is also a very important reaction. So let's finish this off with another one particular reaction. So our Fe is there, CH2, and then NHMe2. So this will have a positive charge because it has 5 bonds. Nitrogen should have 1, 2, 3, 4 bonds. Okay, nitrogen should have only 3 bonds, right? So now our reagent is Na plus CHCO Me2 minus. Okay. So why this is minus? If you see, CH is present, COMe is present, COMe is present. Only 3 bonds and 2 electrons will be present. Carbon should have how many electrons? Totally valence 4. But this has 5. 1, 2, 3, 4, 5. That's why it is minus. Okay. So now what will happen is this will go and react here, and so this is a very good leaving group, right? So because N with lone pair and 3 bonds, of course it's a very good leaving group. So R CH2, so CH2 is here, I have written that, and that CH2 is attached to our particular group, CH COMe. So whatever reaction they give you, whatever reagent they give you, you should know how to do this. Okay, then only it is easy. Okay, if you like this video, like, share and subscribe my video. Thank you for watching this video. If you have any doubts, of course you can tell in the comments. Thank you.